All right, so the first calculus skill we need to learn about is something that's either called differentiation, or sometimes it's also referred to as taking the derivative. Okay, so those two terms we got to kind of get used to. And what this process does, what I'm going to show you here, is it gives us two pieces of information. Number one, if we have a graph, we can use this process that we're going to talk about, and what it'll do is it will find a formula, a function for the slope. So we're talking about graphs that are kind of messy, okay, where the slope is not a constant thing. And so this process of differentiation or taking the derivative, it allows us to determine a function, a rule, for what the slope is at any particular moment or any particular time. The other thing it does is that if we have a function that's, say, x, it will transform that x function, that information about x, and it'll turn it into something about the velocity. It also can take a velocity function and it can transform it into information about the acceleration. So it allows us to take one type of information, like a graph, and determine slope, which again is going to be typically velocity and so forth. Or if we have information as an equation, as a function of time, we can transform it into a different type of equation. So the videos from the U of I show these images, and so I want to talk a little bit about those before you watch them again. They're going to talk about how, if you look at average velocity, you're comparing two specific points, and you're looking to see approximately how fast was the object moving during this region of time. And you look at where it was to start with, where it was later, and you just kind of figure out on average what is its approximate value. But the idea is that if you really want to know the instantaneous velocity, what the value of v is at a particular moment, you got to do more than that. You got to look at a value of time that is so small that it's like non-existent, that this delta t that they're showing you here, that it gets so small that the 2 points really kind of become one. And then that slope really is the velocity at that moment. And you can't just do this with regular math. This is where the ideas of calculus come in. And I'm not going to go through, this is wrong, this is supposed to be an x here. I'm not going to go through and specifically show you why this works. That's what the entire class of calculus does. What I'm going to show you is how to perform it, how to make it work. So at the bottom of this slide, I have written how this rule that I'm going to explain, how it's written on our AP formula sheet, because it is available to us. It's just that they write it in kind of an odd way. I'm going to rather show you some examples, and I think it's easier to see the pattern by looking at that. So let's say I am told that x is equal to 10 times t plus 4. So I'm going to tell you right now, I'm just going to show you the rule, that the velocity, which is also written dx dt, that's how the derivative is written. This is red, the derivative of x with respect to time, that is going to just be 10. Okay? So that should kind of make sense, because this is like the constant speed idea, the slope of this line would just be 10. And so that kind of makes sense, hopefully, that would match up. Let's look at something a little bit more complex, though. What if x was equal to 4 times t plus 3 times t squared? Okay, then it turns out that if I wanted to find the velocity function, which again is called dx dt, the derivative of position with respect to time, here's what the answer is. 4, so that kind of makes sense, same sort of pattern, plus 6t. I'm going to do one more here. Kind of look at this pattern here. If x was, let's see, 7t cubed minus 3t to the 4th power, then my velocity would be the derivative of that function with respect to time, and it would be 21t squared minus 12t to the 3rd power. So I want you to notice what I'm doing here. I'm following the rule basically that's down below. And the rule says that if you have an exponent, you reduce that exponent by 1. That's what this part is saying. Okay, so if the exponent in the original function is n, the exponent in the new function is going to be n minus 1. But then I also use that original exponent one more time. I multiplied it by whatever my original function was. So this was a 3. I took 3 times the 7. That's where I got the 21. I took the 4 times the negative 3. That's where I got the negative 12. Okay, so that's the rule that we're going to practice in class. By the way, if you do have some sort of constant thing, like here, notice that it just completely disappears on the other side. You don't see it because velocity is the rate of change of x. And this is just the initial point. That doesn't really affect how fast something is going. It just sets the initial condition. And so you don't actually see the constant show up when you take the derivative.